Let's just do another example. I've just switched up the values. So we know the gradient and we know a coordinate on the line. So therefore we can just use the equation and do y minus y1, which is going to be minus 7, so it's going to be plus 7, is equal to m, which is 5 over 4, x minus x1, which is going to be minus 3, so it's going to be plus, because remember minus minus is a plus, so it's going to be x plus 3. So if we expand this, it's going to be y plus 7 is equal to 5 over 4 x plus 15 over 4, and if we move this onto the other side, we're going to get 5 over 4 x minus y 50 plus 15 over 4 minus 7, which is going to be minus 13 over 4 is equal to 0. Remember that we need to make all the numbers integers. So to do this, we can times everything by 4 to get 5x minus 4y minus 13 is equal to 0. Of course, you could put the minus in front of this like this, and you would get it's still valid answer like this. But hopefully you're really starting to appreciate the power of this equation here, as all you need to do to really quick put it into this form, ax plus by plus c is equal to 0, is sub in the gradient and sub in one point on the line, just one any point, any coordinate on the line, and you can easily convert it into this form. A very common exam question they could ask is to not give you the gradient, but to give you 2 points on the line instead. Now, the first thought that might be going through your head is, well, how can we use the equation from before? Because we need to know m in order to do it. It doesn't matter if we know 2 points on the line. It doesn't matter, we need to know m in order to use it. Well, if we have 2 points, remember that we can find m by using the formula y2 minus y1 over x2 minus x1. So we can sub the values in and say that 2 minus 5 over 1 minus 3, and that's going to be equal to minus 3 over 4. Of course, you could do this the other way and do 5 minus 2 over minus 3 minus 1 and give it the same thing. But now we know the gradient, so we can actually use this equation now and do y minus y1, and we can use either of the points here as they both lie on the line. I'm just going to use 1, 2, but you could use minus 3, 5 and you'll get the same answer. So y minus 2 is equal to minus 3 over 4, which is the gradient, x minus 1. Remember, you have to use 1 because you have to use the same pairing. You can expand this to do y minus 2 is equal to minus 3 over 4 x plus 3 over 4, and then you can bring the x onto the other side to do 3 over 4 x, bring everything onto the other side, do 3 over 4x plus y minus 2 minus 3 over 4, which is going to be minus 11 over 4, which is equal to 0. Remember, we need to make everything integers, so we can times everything by 4 to get 3x plus 4y. Remember to times this by 4 minus 11 is equal to 0, and that is the equation of line A. Of course, again, you could have done this in a different way, and then you would have got minus 3 at the front and done minus here and plus here, and that is a valid way to write it as well. So here's a question on the equation of a straight line, so pause the video, have a go, and I'll go through the answer in about 5 seconds. Okay, so for part A, it's the question that we kind of went through before, about that they don't give us the gradient, but they give us 2 points, so we can find the gradient by doing 12 minus 3 over 11 minus 1, and if we put that into a calculator, we'll find that as 3 over 4. Once again, you could do 3 minus 12 over minus 1 minus 11, and it will get you the same answer. So now we've got the gradient, we can use the formula y minus y1 is equal to m x minus x1. So we can do y minus y1. We can use either of the coordinates. Once again, you can use either of them and you'll get the correct answer. I'm just going to use this one, this coordinate here. So it's going to be y minus 12 is equal to 3 over 4 x minus 11. We can expand this to get y minus 12 is equal to 3 over 4 x minus 33 over 4. And then we can bring this onto the other side to get 3 over 4 x minus y minus 33 over 4 plus 12, which is equal to plus 15 over 4, which is equal to 0. Now in this example they've been nice and reminded you that a, b and c need to be integers, although regardless, even if they say it or not, a, b and c will always have to be integers. So the way you can do this is to times everything by 4 to get 3x minus 4y plus 15 is equal to 0, and this is the correct answer, although once again you could times everything by minus 1, and you could say, so it could be minus 3x plus 4y minus 15y if you rearranged it in the other way, and that would be a valid answer as well. For part B, we need to find the one point of intersection, because it says point of intersection, so it's only 1 point, and we need to find the point of intersection between the equation that we figured out before and this line here. So remember that this is simultaneous equations. Basically, we need to find the x and y value for which this is true. We could do this by substitution, or we could do it by elimination. I'm going to do it by elimination because I think that's quicker. So I'm going to write this as 3x minus 4y plus 15 is equal to 0. I'm just going to rearrange the other equation slightly to 4x plus 3y minus 30 just to get it in a neater form. And then what I'm going to do, I'm going to times this equation by 4, and I'm going to times this equation by 3 to get the x coefficient the same. So if I do this, it's going to be 12x minus 16y plus 60 is equal to 0, and this one is going to be 12x plus 9y minus 90 is equal to 0, and then we can minus these from each other, and if we do this, the 12x is going to cancel out. It's going to be minus 16y minus 9y, which is going to be minus 25y, and it's going to be 60 minus 90, which is 60 plus 90, so it's going to be plus 150 is equal to 0. Let's give minus 25y is equal to minus 150, so y is going to be equal to 6. And then what we can do is just put 6 into one of these lines, and we can get the x coordinate. I'm just going to use this one, but you could use the other one. So it's going to be 3 times 6, which is 18, plus 4x minus 30, which is equal to 4x minus 12, which is equal to 0. So this here is what we're working with. I've just done 18 minus 30. And then it's going to be 4x is equal to 12, so then x is equal to 3. So therefore the coordinate of the point of intersection is 3, 6. What you could do to check your answer is you could put these numbers on the other side of the equation, and then you could actually put the simultaneous equations into your calculator to check that you get these same x and y values out. Although once again, you shouldn't use that as the only way to figure out. You shouldn't use that to get to the answer, because you need to show a method to get some marks. But what you could do is you could put the simultaneous equations into the calculator to check that you do get these values out, so therefore that you know you've got the right answer.